Alrighty, this worksheet is on kinetic and potential energy, homework number 2. What I did for you guys is I went ahead and put the equations up top, but I did want to clarify that potential energy is just mass times gravity times height. The only reason why this says 9.8 meters per second squared is because that's part of a unit, okay? 9.8 meters per second squared is the acceleration of gravity. That's all you need to know about that. So if you serve a volleyball with a mass of 2.1 kilograms and the ball leaves your hand with a speed of 30 meters per second, the ball has kinetic energy, and that's because it's moving energy. So we already know that we are going to be using the formula. Kinetic energy is equal to 1/2 mass times velocity squared. So all you have to do here is plug and chug. We know that the mass is equal to 2.1 kilograms. We know that the velocity is equal to 30 meters per second. But we don't know what kinetic energy itself is, so we need to go ahead and put that into the problem. All we have to do is kinetic energy is equal to 1/2 times 2.1 times 30 squared. First, what I would do is 30 squared, and you would get 900. And then this isn't going to change, 2.1 and 1/2. All you have to do now is multiply 1/2 times 2.1 times 900, and what you'll get is 945 joules because we are looking at energy. For the second problem, you guys are going to have to identify what type of energy it is and also solve it. So a baby carriage is sitting at the top of a hill. It's sitting at the top of a hill that is 50 meters high. The carriage with the baby has a mass of 40 kilograms. The carriage has blank energy. Is this stored energy or moving energy? Stored energy. So it would be potential energy. So we know for that equation, you have potential energy is equal to mass times gravity times height. And because this baby carriage is on Earth, we know that gravity is equal to 9.8 meters per second squared. We know that the mass is 40 kilograms. And we also know that the height is 50 meters. So I want you guys to think about how we would solve that problem. Because we know these three variables, we can solve this problem all the way through without rearranging the equation. So all we have to do is we know that potential energy is equal to mass times gravity times height. So all we have to do first is we know the mass is 40 kilograms. We know that gravity is 9.8. And we know that the height is 50 meters. Our units are correct because we have meters per second squared, we have kilograms for the weight, and we have meters for the height. So all we have to do is 40 times 9.8 times 50, and you should get 19,600 joules because we're talking about energy. Now those are two basic problems where you did not have to rearrange the equation. As we go on, you're going to have to rearrange some things. So let's try this one. A car is traveling with a velocity of 40 meters per second and has a mass of 1,120 kilograms. The car has what energy? Well, if the car is traveling with a velocity, there's a speed associated, and that integrates that we have moving energy. So we have kinetic energy. So the units for that, the equation rather, is kinetic energy equals 1/2 mass times velocity squared. We know that the mass is 1,120 kilograms. We know that the velocity is 40 meters per second. So now we just need to solve. Kinetic energy is equal to 1/2, that's always got to be there, times the mass, which is 1,120, times the velocity squared. So we're going to do 40 squared. To simplify this, we need to do the exponents first, okay? So this isn't going to change. We're going to have 1/2 times 1,120. But 40 squared is the same as 40 times 40, and that equals 1,600. From here, all you have to do is multiply it through. So 1/2 times 1,120 times 1,600, and that gives us a kinetic energy of 896,000 joules. Because again, we're talking about energy. For number 4, a cinder block is sitting on a platform 150 meters high. It has a mass of 96 kilograms. Okay, if we're talking about height, that's usually a telltale sign that we are talking about potential energy. But also it says sitting, so it's at rest. So it is indeed potential energy. And the potential energy formula is equal to mass times gravity times height. And remember, this is on Earth, so gravity is going to be 9.8. So the mass is 96 kilograms, which is in the correct unit. Gravity is going to be 9.8 meters per second squared, and that's in the correct unit. And then we have height, which is equal to 150 meters, which is also in the same unit. So all we have to do is plug this in and solve. So potential energy equals mass times gravity times height. So we know that our mass is 76. We know that gravity is 9.8. And then we know that height is 150. If you type into your calculator 96 times 9.8 times 150, you should get a potential energy of 141,120. What are the units for energy? Joules. All right, last one on this page. There is a bell at the top of a tower that is 45 meters high. The bell has a mass of 4,600 kilograms. What type of energy does it have? Is the bell moving? No. So it has potential energy. And that potential energy formula is the same as it get above. Potential energy equals mass times gravity times height. We know that the mass is equal to 4,600 kilograms. We know that gravity equals 9.8 meters per second squared. And we also know that the height is equal to 45 meters. All we have to do, same thing as before, potential energy equals mass times gravity times height. So 4,600 times gravity, which is 9.8, times 45. All you have to do from here is multiply these together and then decide what our units are going to be. $4,600 times 9.8 times 45 gives us a whopping 2,028,600 joules. Go ahead and flip it to the back and do these last few problems. For number 6, a roller coaster is at the top of a 72-meter hill. It has a mass of 1,400 kilograms. The coaster at this moment has what energy? It's just at the top. Because it's not actively moving and it's paused for a slight moment, it indeed has potential energy. And as a reminder, that equation is going to be potential energy equals mass times gravity times height. So let's break this down. The mass, 1,400. Gravity, 9.8 meters per second squared. And the height is equal to 72 meters. All we have to do is plug these in. Potential energy is equal to 1,400 times 9.8 times 72, and you will get 987,840 joules. 2 more. For number 7, what is the kinetic energy of a 3-kilogram ball that is rolling at 2 meters per second? Just because I spelled out these words, do not let them trick you up. We know that the kinetic energy formula is 1/2 mass times velocity squared. What is this word problem telling us? It gave us mass. Mass is equal to 3 kilograms. It also gave us velocity, which is 2 meters per second. So guys, all we have to do is plug this into the equation. Kinetic energy is equal to 1/2 mass times velocity squared. So 1/2 3 times 2 squared. So if we're solving with PEMDAS, please end my day at school. We need to go ahead and do the exponents. 2 squared is equal to 4. The 3 is not going to change, and the 1/2 is not going to change. Now we just have to multiply this through. 1/2 times 3 times 4 gives us 6, and our units will be joules. For this next problem, I'm going to go ahead and start at letter A, but I do want to give you the preface to number 8's question. So 2 objects were lifted by a heavy machine. We've got one object, so let's say object number 1, has a mass of 2 kilograms and was lifted at a speed, so a velocity, of 2 meters per second. Then there was the other object with a mass of 4 kilograms and was lifted at a rate of 3 meters per second, so a velocity of 3 meters per second. Letter A says, which object had more kinetic energy while it was being lifted? So let's figure this out. If we know kinetic energy is equal to 1/2 mass times velocity squared, we can easily figure out this answer by just doing this equation to both of the problems. So for number 1, all we have to do is 1/2 times 2 times 2 squared, because we have 2 kilograms and 2 meters per second. This will simplify down to 4 times 2 times 1/2. And from there, if you multiply that through, it'll give us the same answer as before, which is 4 joules for number 1. Let's do number 2. We know that the mass is 4 kilograms, we know that the velocity is 3 meters per second. So 1/2 times 4 times 3 squared. Let's solve this through. 1/2 is not going to change. 4 is not going to change, but 3 squared, that gives us 9. When you multiply 1/2 times 4 times 9, that then gives you 18 joules. So which object had more kinetic energy? Number 2. Exactly. So for part B, it's asking which object had more potential energy if it was lifted to a distance of 10 meters. Show your calculation. We know that potential energy is equal to mass times gravity times height. And the height is given. So let's separate these 2 objects. For number 1, we need to know the mass, we need to know gravity, and we need to know height. Height's going to be 10 meters. Gravity is going to be the exact same thing as it always on Earth, which is 9.8 meters per second squared. And our mass is going to be 2 kilograms. Okay? All we have to do is multiply this through. So potential energy is equal to the mass, which is 2, times gravity, which is 9.8, times 10. When you multiply those numbers through, you find out that the potential energy is 196 joules. All right, let's see about number 2. Same idea. Let's do this again. What's the mass? What's gravity? And what's the height? So the mass of this one is 4 kilograms. The gravity is going to be the same, of 9.8 meters per second squared. And the height will be 10 meters. Now, guys, looking at these two things, even without adding it, if I didn't ask you to show your calculation, couldn't you tell that object number 2 is going to have more because we've got a greater mass? That's what I want you guys to be able to conceptualize when I ask you about these equations, okay? So all you have to do is potential energy is equal to 4 times 9.8 times 10. And when you multiply those numbers, you get 392 joules. So as we stated before, number 2 has a greater potential energy. Thanks, guys.